Research strategy refers to the general approach and goals of a research study. So the selection of a research strategy is usually determined by the kind of questions you plan to address and what you hope to accomplish. Okay, so a couple of different strategies, and we'll cover each in more depth throughout the semester. So descriptive research describes individual variables as opposed to talking about the relationship between variables. So typically descriptive research obtains a snapshot or a description of specific characteristics or of a specific group of individual. So normally data are in the form of averages or percentages. So we might talk about something like average time to graduation or average age of graduation or retention rates, but we're not looking at how these relate to other variables. However, sometimes we want to know more than just describing a variable. We want to know relationships between variables. So maybe, I don't just want to know the average amount of time that kids spend staring at screens. I want to know how that screen time influences other things like academic performance, or whether different types of screen time are worse. Are they bad for language development? Does screen time influence social skills? There's lots of ways that I might want to look at how a specific variable of screen time is related to other variables. Most of the research that we do in social sciences is not just descriptive, but it examines the relationship between variables. So we want to know how change in one variable is accompanied by change in other variables, in another variable. So relationships between variables can be linear, meaning they're a straight line, curvilinear, meaning it's not necessarily a straight line and it may curve in various directions. It can be positive, meaning as one variable goes up, so does the other one. Or they can be negative, meaning the variables move in opposite directions. When one variable increases, the other decreases. So this is figure 6.1 in your book, and it's examples of different types of relationships between variables. So A is just kind of a general relationship, and you can see that it's categorical. We've got people who are in the early wake-up group versus a late wake-up group, and we're relating it to the grades that they get in class. Variable B is, graph B shows a linear relationship between the variables x and y, and it's positive. You can see that people who score low on variable x also have a low score on variable y. People who score low on variable x also score low on variable y. People score high on variable x also score high on variable y. So this is a positive linear relationship. In graph C, we have a negative linear relationship where the variables are in opposite directions. So high score or low score on x means a high score on y, and conversely, a high score on x means a low score on y. And then the last one is showing a positive curvilinear relationship, and there's lots of different varieties of that. So we'll have separate chapters on each of the ways that we go into, that we try to assess the relationship between variables. So I won't go into them in too much detail. But one strategy is looking at correlations. So a correlational research strategy will always measure two variables from the same person. So for example, if I want to know the relationship between GPA and sleep habits, maybe something like wake-up time for college students, each person in my study is going to provide me with a measure of their GPA and report on their sleep habits. So when we have correlational data, consistent patterns are better seen in a graph called a scatter plot, and basically each individual is represented by a point. Now the big caveat with correlations is correlation does not imply causation. So correlation describes a relationship between variables, but it doesn't explain why that relationship is happening, and there are alternative explanations. So this is what data from a correlational study might look like. Each person is represented by a letter, and for each person we have data on their wake-up time and their GPA scores. So when we convert that into a scatter plot, we get a graph like this where each dot represents a person. So we can look, person A had a wake-up time of 11 and a GPA score of 2.4. And so we know that this is person A right here. And so we plot all of the people together. It gives us a scatter plot. So it looks like there is generally a negative relationship between GPA and wake-up time. We can see that there's this downward trend where people who wake up later tend to have a lower GPA. So we can say that maybe we find a correlation between GPA and wake-up time, but that doesn't tell us why. It could be that waking up early directly improves someone's GPA. It could be that being smart enough to get a high GPA makes you wake up early. It could be something entirely unrelated. So maybe being a student athlete means you have to wake up early, and it also means that you are smarter. We might also, rather than look at the relationship between two naturally occurring variables, we might compare two or more sets of scores. So rather than looking at things in a continuous way, we're comparing two or more groups. So there's a couple of different methods that use this strategy, including experimental, quasi-experimental, and non-experimental strategies. But what we're doing is comparing two or more groups of scores. We've got one variable that kind of differentiates what group people are in, and a second variable where we get scores from every individual, regardless of their group. So for example, maybe I want to compare the grades of students who are from high and low income families. So I'm going to ask every participant about their family income. And with that information, I can place students into a high income group and a low income group. And then I'm also going to ask every single person about their grades. And so for all of my high income people, I have their individual scores, and I can calculate a mean for my high income people. Then I have the individual scores for my low income people, and I've got a mean for that group. And I'm going to compare the two groups. So when we're comparing groups, there's a couple of different approaches. Like I said, with an experimental research strategy, we're able to get into cause and effect. So with an experimental strategy, we're going to manipulate one variable and measure how it affects another variable while we control everything else. So in an experimental strategy, the goal is really to explain the relationship by determining the underlying causes. With a quasi-experimental strategy, the goal is to answer cause and effect questions, but we don't have as much control. So quasi-experiment means almost experiments. We can never produce a completely unambiguous explanation, because with a quasi-experiment, often we're using pre-existing groups, so we're not truly manipulating our variable. So in contrast, with a true experiment, we would do something like randomly assign kids to get tutoring or not get tutoring, so that we could prove that tutoring definitively causes students to do better. In a quasi-experimental study, we wouldn't be able to randomly assign kids, but maybe we just have one class that gets extra tutoring and one pre-existing class that doesn't. So we can't definitively say that it's the tutoring as opposed to something else that happened in class that led to the change. And finally, a non-experimental research strategy demonstrates the relationship between variables, but does not attempt to explain it. So we'll talk about that. We have a separate chapter on that. So when we use non-experimental and correlational research, both are designed to demonstrate a relationship that exists between two variables. So we're just looking at the relationship. We're not trying to explain it. So these are similar to correlational studies in that they try to identify whether there's a relationship between the variables without explaining it. However, the types of data differ. So with a correlational study, we're using one group of participants, and each participant is providing us with two variables, two pieces of information. In contrast, in a non-experimental study, we're comparing two groups of scores, and each individual only provides us with one piece of information. So maybe if we're looking at gender differences in memory, we've got memory information from men and memory information from women, and we're going to compare them. But those two pieces of information come from different people or different groups. So the 5 research strategies that we'll talk about are kind of hierarchical in terms of how the quality of explanation. So category 1 is descriptive. So these are strategies that examine just individual variables. So the purpose is to provide a description of individual variables as they exist within one group of people. And normally our data is a list of scores obtained by measuring each individual in a group being studied. So for example, I might be able to say something like, on average, local college students study 12.5 hours outside of class each week and get 7.2 hours of sleep each night. Category 2 is correlational. So these are strategies that examine relationships between variables by measuring 2 or more variables for each participant. So here, the purpose is to produce a description of the relationship between 2 variables, but do not attempt to explain the relationship. Okay, so we're just identifying whether or not there is a relationship. And the data is 2 or more variables, 2 scores for each individual in a group being studied. So for example, there's a relationship between wake-up times and GPA for college students, but we don't know why. And as I'm going through each of these, I encourage you to be thinking about your own final project and thinking about what kinds of information are you going to collect, and where does your study kind of fall in these different categories. The third category is strategies that examine relationships between variables by comparing 2 or more groups of scores. So this includes experimental, quasi-experimental, and non-experimental. So the purpose here is to produce a cause and effect explanation for the relationship between 2 variables. And so our data for an experimental study involves creating 2 treatment conditions by changing the level of one variable and then measuring the second variable for participants in each condition. We'll spend a lot of time talking about experimental studies. But an example of this might be something like increasing the amount of exercise a person does. So you'd have the amount of exercise would be one variable, and maybe one group gets 5 minutes of exercise a day and another group gets 45 minutes a day. And the experimenter tells people how much to exercise, and maybe we think exercise affects cortisol, and so we measure the amount of cortisol that people have after their exercise. Quasi-experimental studies also fall into this third category. So here the purpose is to attempt to produce a cause and effect explanation, but we don't quite get there with the data we have. Our data measures before and after scores for one group that receives a treatment and a different group that does not receive a treatment. This is kind of a classic quasi-experimental. So for example, we might do a study where we measure smoking before and after a smoking intervention, and we find that people smoke less after the smoking intervention, but we can't definitively say that it was only the intervention that caused the reduction in smoking. Non-experimental studies also fall into category 3. The purpose here is to produce a description of the relationship between 2 variables, but it doesn't attempt to explain the relationship. Okay, so the data here is that we measure scores for 2 different groups of participants, or for one group at 2 different times. So maybe we have a theory that there's a relationship between gender and verbal ability. So we measure verbal ability for men and women, and we find out that there's a difference. It doesn't tell us why there is a difference. Okay, so those 3 are the most common research designs or research strategies, sorry. And a research strategy is kind of your general approach and the goals of a research study. These are determined by the type of question that you plan to address. So in contrast, a research design is how you actually implement the research study. So it requires decisions about 3 basic aspects of your study. So you need to think about whether you want to study the group or the individual. So are we going to closely examine one group of people, or maybe do a kind of surface, less deep exam of a large group of individuals. We also need to think about, are we going to look at the same individuals or different individuals? So are we going to study change over time within one individual? So do like a longitudinal study, or do we want to look at individuals in different types of treatment groups? Third, we also need to make a decision about the number of variables that we include. The simplest study probably just includes 2 variables, but sometimes we may assess more. But these research designs provide a general framework for conducting studies. The procedure details precisely what will be done. So what exactly are we going to do? So this is a step-by-step description of a specific research study. We talked about some of these things in Chapter 3 when we talked about defining and measuring variables, and in Chapter 5 when we talked about identifying our participants. So we have to figure out exactly how variables will be manipulated, regulated, and measured, how many individuals will be involved, how the individuals will proceed through the course of the study. We also have to consider the fact that different strategies lead to different types of analyses. So if we're doing experimental or quasi-experimental or non-experimental studies, we're typically comparing groups of scores. So we might use things like t-tests, analysis of variance, or chi-square tests. In contrast, if we're doing correlational studies, if we have numerical data, so for example, responses on a Likert scale, we would analyze them with a correlation, so things like a Pearson correlation. If you had non-numerical data, we might use a chi-square test. And then finally, if you have descriptive studies, where you're summarizing a single variable for a specific group of individuals, if you have numerical data, you might do statistical calculations of the mean and standard deviation. If you have non-numerical data, so groups, you might report the percentage associated with each category or something like that. We're going to talk about each strategy in detail. In this chapter, when we talk about validity, we're talking about how well each strategy answers the question they're intending to answer. So validity, again, is about the truthfulness of a research study or the accuracy of the conclusions. We already talked about validity in terms of how it applies to specific measurements and questionnaires. Here we're talking about the validity of an entire research study. Does it assess what we are trying to measure, and kind of what is the quality of a study? So with external validity, we want the results to be generalized beyond the study. So can we generalize to other populations, settings, and measurements? With internal validity, this is something we're particularly concerned about for experimental studies, and we're looking at factors within a study that might limit whether we can be certain about the cause and effect. So is there something else in the study that could explain the findings? So again, external validity is about the extent to which the results of a research study can be generalized. And in terms of threats to external validity, it would be any characteristic of a study that limits the ability to generalize the study's results. So a good researcher will anticipate the threats to validity and address them during planning, but it's not always possible to take into account every possible threat to a validity. So sometimes we have to ignore the less important threats. Research studies vary in terms of their validity, but it's determined by the extent to which a study satisfies the criteria of internal and external validity. So a threat to validity, again, is any factor that generates doubt about the accuracy of the results or raises questions about interpretations of the results. We never accept research result or conclusion as true simply because it's been scientifically demonstrated. Just being aware that there are threats to internal validity can help you critically evaluate a research study. And then you can make your own decisions about the research report's validity and quality. So be thinking about these things both as you're designing your own study, but also as you're reading and evaluating other research. So threats to external validity is a characteristic of the study that limits the ability to generalize the results. Okay, so there's 3 different categories of threats to external validity. The first is generalizing across participants or subjects. So is there something unique about the people who did the study, who participated in the study, that means that we can't generalize to a broader population? So just an example of this is Kohlberg is famous for his work on studying moral development in children. And all his work was done on adolescent males. And so people have questioned whether his findings actually have external validity and do they generalize to adolescent females and other groups. So if your study doesn't necessarily generalize to other groups, then it has limited external validity. So this first point is about generalizing from the sample to the population. And this is, of course, a basic assumption of research. The next category is about generalizing across features of a study. So this is about replicability, right? So we've talked about replication. If somebody does the exact same things that we did in a different study, would they find the same results? The final point, category 3, is about generalizing across features of a measure, or features of the measure. So this is really about generalizing to a real world situation. So if we think about Milgram's study on obedience to authority, where participants thought they were shocking a learner who was actually a Confederate, the question is, are people who shocked the learner in Milgram's contrived experiment more likely to be aggressive in day-to-day life? Or was it just something specific about the situation? So again, all of these questions are about how much these results generalize beyond the context of the experiment. And that's what we're talking about when we talk about external validity. So when we're thinking about how much do threats, or these threats to generalizing across participants or subjects, we're talking about to what extent can the research be generalized to individuals who differ from those who participated in the study. So there's a couple of different ways this might happen. One is selection bias. So maybe our sampling procedure favored the selection of certain individuals. If our sampling didn't accurately represent the population, particularly if we're using a convenience sample. Another issue is overutilizing college students. So college students are really easy participants for researchers to get, but their characteristics don't necessarily represent all adults. Another issue is volunteer bias. So people who participate in studies have to be volunteers as part of our ethics. But the people who are willing to volunteer for research studies may have some different characteristics than the average population. Participant characteristics, so the group you selected may not actually represent your population. And then cross-species generalization. So principally when we conduct animal research, we have to think about, do those findings generalize to humans? So this threat has to do with to what extent the results of a study can be generalized to other procedures for conducting the study. There's a couple of effects that could go into this. So novelty. So because participating in research is new and exciting, it could lead to different performance. Especially because it's a very prescribed situation in an experimental study, behaviors may differ. Multiple treatment interference is particularly an issue if we're having people participate in more than one treatment condition. They might either get tired or get better with practice. So this is something we worry about with repeated measures designs or within subjects designs where people are doing multiple conditions. And then experimenter characteristics can also play a role. So sometimes the experimenter behavior can influence the participant behavior, and just the experimenter's demographics can influence the participant behavior. Okay, so the next one is about to what extent can the results of study be generalized to other ways of measuring the study. So one issue is sensationalization. So maybe just the process of measuring a variable can change the way participants respond. So we're worrying about, do the results of the study generalize to the real world? So if we ask people about helping behavior and then put them in a situation where we measure how much they help someone, they may have heightened awareness of helping behavior and behave differently than they would in the real world. So this can particularly be a problem if you do like a pre-test, which cues participants to what you're studying. Issues of generality across response measures. So there's lots of different ways to measure the same variable. And so you could have some effects that just have to do with the specific measure used. And then the time of measurement. So in a study, we pick kind of when we measure individuals and only measure them at one point in time. And so the effects that we're assessing could be longer or shorter lived than what we actually measure. So for example, if we look at a weight loss program, we might find it's more effective than a control group 3 months out. But if we measured weight loss at 9 months, we might see that it's actually not effective. So even if we're measuring longitudinally, we're only getting a snapshot of what's happening. Okay, so when we talk about internal validity, we're concerned about factors in the research study that raise doubts or questions about the interpretations of results. So a research study that has high internal validity produces a single, unambiguous explanation for the relationship between two findings. So if you have high internal validity, every single thing that happened in one group happens in another, and the only difference is the variable that you manipulate. Therefore, it's the only possible explanation for your findings. So again, internal validity is particularly important for an experimental study. And so for the definition, we're concerned about factors in the research that raise doubts or questions about the interpretation of results. And threats to internal validity are basically alternative explanation for the findings. For a research study to have internal validity, again, there has to be one and only one explanation of the results, and we need to make sure that the only difference between treatment conditions is the variable that is used to define the conditions, the independent variables. So some things we need to think about are extraneous variables. So extraneous variables are any variable that is in a research study other than the specific variables being studied. So basically other things that aren't measured but could affect results. Confounding variables are extraneous variables that are usually unmonitored, but they provide an alternative explanation for the observed relationship. And so confounding variables change with the variables in the study. So for example, if I'm interested in whether school tutoring improves grades, and I have one group that gets tutoring and another group that goes home alone for several hours after school, if I find a difference in performance between my two groups, I can't be sure if it's the tutoring or if it's just being home alone, because that being alone after school is a confounding variable. It's not just that students get tutoring or no tutoring, it's that they get tutoring and social interaction. And so the social interaction could affect my results. So of course, this is a big question or threat to internal validity. So 3 general types of threats: environmental variables. So environmental variables are differences in the room where the study was conducted. Things like temperature and color could lead to differences between groups or explain differences between groups. There are participant variables, so height, weight, IQ, personality. All studies have some individual differences between participants, and when we talk about studies that compare groups, we try to distribute them evenly between conditions, but this is always kind of an alternative explanation. So for example, if we go back to the weight loss example, we have a group that gets a weight loss treatment versus no treatment. My treatment group averages 175 pounds and my control group averages 200 pounds. If I find no change, I don't know if it's a matter of the treatment not working or if it has something to do with the initial weight differences. And then finally, time-related variables. So time between treatment conditions, especially if looking over time, so different weather, different stressors, more practice, all those things can be threats to internal validity. Okay, so researchers want to be confident that their results are true and their findings extend beyond specific individuals, conditions, and procedures of the study. So the goal is to maximize internal and external validity. But sometimes this is kind of a balancing act. So to get internal validity, we have to exert a lot of control to minimize those extraneous and confounding variables. But the more control we have in a study, that means that the less the study looks like the real world, and therefore the less external validity we have. If we, in contrast, try to get high external validity and the environment looks a lot like the real world, sometimes we allow for extraneous variables that will decrease internal validity. So we've got this constant trade-off between internal and external validity, and sometimes we have to let the purpose of the study or the goals help us decide which type of validity is maybe more important or which threats we can versus cannot address. So we discussed artifacts in chapter 3, and there are external factors that distort our measurement, and they can be threats to both internal and external validity. And so experimenter bias is an example of this. It threatens external validity because if the experimenter's behavior influences findings, then a different experimenter might have different findings. And it threatens internal validity because patterns that appear to be a treatment effect are actually because of the experimenter influences. So single or double-blind studies can address this. Demand characteristics are features of a study that tell a participant about the purpose or hypothesis or influence participants to respond in a certain way. And so these can also influence validity. Reactivity is when participants modify their behavior because they're in a study. So again, this threatens internal validity because if they're not acting normally, then the results can be explained by reactivity rather than the actual differences between groups. And it threatens external validity because the results are coming from demand characteristics and won't generalize to a new situation when the environmental demands are different. Another issue is exaggerated variables, where when the goal is to find the difference between groups on one variable, we create a situation where the differences between groups are really pronounced, but it doesn't necessarily generalize to the real world. So for example, if we're interested in difference in compliance rates between someone who's nice versus mean, we get someone who's nice versus mean. We get a researcher who's really nice and someone who's really mean and look at the differences that in responses, but that's more subtle in the real world. So of course it doesn't have this external validity. So we're going to keep coming back to these ideas of internal and external validity. The issues that we're concerned about vary depending on our experimental or on our research design.